Okay, in this lesson, we are going to learn about understanding probability of simple events. In this lesson, you're going to learn about three different standards: SP5, SP6, and SP7. And all three of these standards deal with understanding theoretical probability, what is probability, and experimental probability. Terms to know: possible outcomes, all of the possible results. Sample space. This is all of the possible outcomes. Probability, the likelihood that a chance event is to occur. And probability, your ratio or fraction, is the number of favorable outcomes over or divided by total number of possible outcomes. We'll come back to that in a few minutes. A simple event is an event that only has one possible favorable outcome. And then there are two different types of probabilities you'll be learning about today. One is theoretical. Theoretical, in theory, this is what should happen. It's the ratio of the number of ways the event can occur to number of possible outcomes. And then you have experimental probability, and it's exactly what it says. It is when you're experimenting to find the ratio of the total number of times the favorable outcome happens to the total number of trials. And in theory, it should be close, very close to your theoretical probability. Another thing you need to know: unlikely, closer to 0, likely is closer to 1. For example, if you had a pie chart, and the different spaces you had red, 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 and blue. And it's a spinner, so we spin, and we want to know what is the probability it lands on blue. Okay? There is one outcome that is blue, so that is our numerator. Our denominator is all the different outcomes that are on that pie chart. So we have 1, 2, 3, and 4. So that means our denominator is 4. So you have a 1 out of 4 chance for that spinner to land on blue. Now, unlikely or likely, what we have to do is convert that 1/4 to a decimal by dividing 4 into 1. And we get decimal 25 or 25%. And you have to think to yourself, is 25% closer to 0 or 1? Well, that means if it's closer to 0, which 25% is, it is unlikely that it will land on blue. Now, let's try that again. Let's do it with red this time. Again, the sample space, how many outcomes there are? It's 4. That's your denominator. Red, how many red are there? There are 3. That means 3 is the numerator. 3/4 is equivalent to 0.75, which is also equivalent to 75%. That one is actually close to 1. So that is a likely outcome. That is the difference between unlikely and likely. It's where you take the fraction / probability and convert it to a decimal and figure out which one's closer to 0 or 1. Now, in football, that's the best example I have when thinking about likely or unlikely. At the beginning of a game, think to yourself, what do they always do? They flip the coin. Heads or tails. They choose a coin because it's 50-50. It is an even chance. It is neither likely or unlikely because it is 50-50. Heads or tails, 50-50. That's why they do that in football, to see who gets the ball first. Example 1. Okay, here's an example of probability. A bag holds 8 pieces of paper numbered 1 to 8. Nick chooses a piece of paper at random. How likely is it that Nick will choose a 4? Okay, so your first step when dealing with probability problems is, step 1, find the number of possible outcomes. So in this case, your number of possible outcomes is 8. So that is your denominator. Your denominator is 8. Okay, step 1, done. Step 2, find the number of favorable outcomes. In this case, we're trying to figure out how many 4s he could pull out of the bag. Well, if it's number 1 to 8, there is only 1 4. So your favorable outcome is 1. 2 done. Just wrote the probability. The probability is 1 out of 8 chance. Okay, now we have to think to ourselves, is this likely or unlikely? Well, 1/8 as a decimal is 0.125. That is closer to 0, so that means this is unlikely. Now, put this video on pause for a second, and I want you to do this example. What is the probability Nick will choose an even number? And think to yourself, how many even numbers are there on those pieces of paper? Go ahead, put it on pause and try. Okay, so our possible outcomes did not change. There are still 8 pieces of paper with numbers on it. Now we have to think to ourselves, the even numbers are 2, 4, 6, and 8. That being said, there are 4 different outcomes that are even numbers. That means 4 is our numerator. 4 eighths. Now, I'm not going to leave it that way. Now, I'm going to simplify. We want to simplify that fraction. He's got a 1 out of 2 shot to get an even number. So, in this case, I would say that's likely. I know I said a second ago with flipping a coin, it's neither likely or unlikely. But in this case, I would say it's likely. 50% or above, I would say it's likely. Okay? Let's move to example 2. Theoretical probability. Once again, Josh is going to choose a random card from 13 cards. The cards are numbered 1 to 13. What is the probability that he will choose a card with a number less than 4? Okay, now we have to think to ourselves, does 4 count as less than 4? No, it does not. It is an inequality. So we are looking for x less than 4. Any number that is less than 4 is going to be in this probability problem. Okay, so first step, count the number of favorable outcomes. In this case, 1, 2, and 3 are the only numbers that could be chosen that are less than 4. So 3 is our numerator, 13 is our denominator because there are 13 numbers. Now, that is my theoretical probability. 3 out of 13. I can't simplify that fraction. 3 out of 13 is it. Now, determine, is this likely or unlikely? So let's convert that to a decimal. We're going to divide 3 by 13, and I get decimal 23 or 23%. So in this case, it is actually closer to 0, so that is unlikely. Theoretical probability once again. Julia has a bag with 16 colored marbles in it. Okay, so those are all the outcomes you get. There are 7 green, 1 red, 4 blue, and 4 purple. What is the probability that she will grab a green marble? So go ahead and put this video on pause, and I want you to try that right now. Okay, so your denominator should have been 16. Those are all the outcomes that are in that bag. Okay, what is the probability that she will grab a green marble? Well, we look up there. There are 7 green, 7/16. So the theoretical probability for that problem is 7/16. 7 is a prime number. It is not a factor of 16. There's my answer, 7/16. Now, let's try this. What's the probability? Pull out a blue or purple. Now, our outcomes didn't change. It's still 16. When you see the word or in a probability problem, that means it could be either or. I'm either looking for a blue or a purple. So your probability, for the most part, will get higher. There are 4 blue and 4 purple. That or means add the 2 together, 8/16, which is equivalent to 1/2. So the probability of pulling out a blue or purple would be 1/2. Again, still working on theoretical probability. Peter will roll a number cube labeled 1 through 6 like a normal dice, a total of 90 times. So this is more of an experimental probability, to be honest with you. What is a good prediction for the number of times that the number cube will land on 5? Now, first step, possible outcomes, 6. Next step, find the number of favorable outcomes. In this case, there's only 1/5, so 1/6. That's our theoretical probability. Now, if we did that 90 times, what will we get? So we multiply this by 90. 90 over 6. In theory, so yes, it is a theoretical probability. The 90 times threw me off. In theory, 90 divided by 6, you do this 90 times, you should land on that number 15 times. Now we're in experimental probability. What is the probability that the spinner will land on 2? Okay, so your first step is look at the number of trials, okay? So our number of trials are here. This guy, the number, is just there to throw you off. That's the number that is on the spinner. The 1, 2, 3, 4, 5, 6 is the number that is on the spinner, okay? Now, our first step is to add up our trials. 10 plus 7, 6, 8, 5, and 6. So that means this person spun the spinner 42 times. So 42 would be our denominator. Unlike theoretical probability, where it's the number of outcomes, in experimental probability, it's the number of trials. Okay? Number 2, find the number of outcomes. Okay? Now, so we're looking at landing on 2. So we come to this table right here. It landed on 2 7 times. So that 7 is my numerator. Now we simplify. Divide by 7, and you get 1/6. Well, how about that? In this instance, I got the experimental probability and the theoretical probability are actually the same. Now, that will not always happen. But in theory, your experimental probability and your theoretical probability should be close to one another. Okay? Another experimental probability. Gavin rolls a number cube labeled 1 to 6 a total of 40 times. The number 4 is rolled 8 times. What is the experimental probability of rolling a 4? What is the theoretical probability of rolling a 4? Describe the difference. So I want you to put this video on pause, and I want you to try to find the experimental probability, then find the theoretical probability. Okay, so our denominator for the experimental probability is 40 because he rolled the die 40 times. The number 4 is rolled 8 times. So what that means is this. It landed on 4 8 times, so 8 is the number of outcomes in the experimental probability of rolling a 4. I'm going to go ahead and simplify. The common factor is 8, and I get 1/5. So the experimental probability is 1/5, which is also equivalent to 0.2 or 20%. Now let's go to the theoretical probability. That's your easy one. Okay? There are 6 outcomes. 6 is my denominator. There's only 1 4. 1 is my numerator. 1 out of 6 is equivalent to 0.166 repeating, or 0.167, which is equivalent to approximately, I'm going to approximate here, 16.7%. I rounded. Now, are they the same? No, they are not the same. However, they are close to one another. That's the thing about experimental and theoretical probability. They should be close to one another. And in this case, they are. Another example. Beth wants to perform an experiment. She will toss a colored chip 20 times. Okay, I think you should already know what the denominator is going to be here. The chip has one red side and one yellow side. She wants to compare the experimental probability of the chip landing red side up to the theoretical probability of the chip landing red side up. How do the probabilities compare? Okay, real simple. You should already know the theoretical probability here is just like flipping a coin. Okay? Our theoretical probability here is 1 out of 2. You got 1 out of 2 chances to get red or yellow. Okay, that's real easy. Now, let's look at the experimental probability of landing on red. Well, we've already got that 20 is my denominator because that's the number of trials. Okay? Now we have to go through and count all the red. 1, 2, 3, 4, 5, 6, 7, 8. Okay? 8/20ths. Go ahead and simplify by 4. And I'm going to end up getting 2/5, which is equivalent to 40%. Now, is it 50%? No. But is it close to 50%? Yes. So our experimental probability here is 40%. In theory, though, it should have been 50%. Last but not least, the sum of probabilities. The sum of the probabilities of all possible outcomes is always 1. For example, flip a coin. The probability of heads is 1/2. The probability of tails is 1/2. You add those two together, you get 1. Another example. I have a spinner. 1, 2, 3, 4. Okay? Probability of landing on 1 is 1/4. 2 is 1/4. 3 is 1/4. And 4 is 1/4. You add all that together and you get 4/4, which is equivalent to 1 whole. Always